Hi everyone, here we are back at our second problem in showing different trig identities. So in this specific problem, we would like to show that some trig values added together are equivalent to another, and these ones end up dividing, or their ratios in this end. So what we want to show is that cosine theta over 1 plus sine theta plus 1 plus sine theta over cosine theta is actually equivalent to just 2 over cosine of that theta or angle, whatever we're calling theta. So to approach this, don't get too hung up again in what's going on and what we want to show. We just want to do everything we can to simplify this down or combine everything we can. So in this problem, we're adding two fractions, and if we want to add two fractions, we need common denominators. So when we look at our denominators, well, they don't have anything in common right now. I have a 1 plus sine theta on the left side, and I have a cosine theta on the right side. There's nothing in common there. So what I'm going to do is I'm going to multiply these. I'm going to multiply the left side by cosine theta over cosine theta to get that cosine theta introduced in the denominator. And I'm going to multiply the right side by 1 plus sine theta over 1 plus sine theta to introduce that 1 plus sine theta. So ultimately, here, I want my denominator to be 1 plus sine theta multiplied by cosine theta. So to do that, I need to introduce some values into each of these. So on the left side, we said we're going to take cosine theta over 1 plus sine theta, and we're going to multiply it by cosine theta to get that value in the denominator. So multiply by cosine theta over cosine theta, which is actually just a complicated way of saying 1. So when we do that, we have a cosine squared theta, because cosine theta times cosine theta. And then over here, let's just switch it to be consistent. We have a 1 plus sine theta multiplied by a cosine theta. So in this left side, we now have that denominator that we're shooting for. Now the right side, what we need to introduce is a 1 plus sine theta in the denominator. So similarly, I'm going to multiply this by 1 plus sine theta over itself, which is just a really complicated way of saying 1 plus sine theta. I'm introducing this into this fraction, and I multiply it by the original fraction. So it happens to be 1 plus sine theta in the numerator over cosine theta in the denominator. So here, when we multiply this out, well, we have 1 plus sine theta squared. Let's go ahead and just multiply this out right away. So we have 1 times 1. We have a 1 times sine theta, another 1 times sine theta. So we'll have 2 of 1 times sine theta, which is just sine theta. So there's 2 of those. And then finally, we have a sine theta times sine theta. So we have a sine theta squared, and we notate it with the squared in between the trig and the value it's being taken of. And now our denominator is 1 plus sine theta multiplied by cosine theta. So that's what we wanted. We forced that to happen. So now we're set up to add these. Well, when we add these, we can just add it straight across, or we can reorganize. Well, right now, let's just add these two together. Because they have a common denominator, we can write it as one value over 1 plus sine theta times cosine theta. And what we have is a cosine theta, or cosine squared theta, plus 1 plus 2 sine theta, plus sine squared theta. And this is getting a little messy, but we'll start cleaning it up now. Let's get rid of this red. I'm not sure what that's from. So now what we need to do is clean up that numerator specifically, because there's a lot going on. So just like I mentioned in the last video, we're looking for a Pythagorean identity, which is cosine squared theta plus sine squared theta. We have that. We have a cosine squared theta starting it and a sine squared theta ending it. So if we clean this up a little bit and rewrite it in another way, 1 plus sine theta times cosine theta. We have a cosine squared theta plus sine squared theta. If we put those next to each other, then we have a 1 plus 2 sine theta over there. So now we can rewrite this as 1. So when we rewrite this cosine squared theta, sine squared theta as 1, we have 1 plus 2 sine theta, all over the same denominator. That's not changing, which is 1 plus sine theta times cosine theta. Well, 1 plus 1 is 2, so we have 2 plus 2 sine theta in our numerator, all over the same denominator still. 1 plus sine theta times cosine theta. Well, if I look at the numerator now, I notice 2. There's a factor of 2. So if I factor that 2 out, I have 2 times, well, 2 divided by 2 is 1. 2 sine theta divided by 2 is 1 sine theta. So we have a sine theta left when we factor that 2 out. And then we have a 1 plus sine theta in the denominator, which hasn't changed, and then times a cosine theta. So now we actually see that we have this common factor in the numerator and denominator that we can reduce to 1. 1 plus sine theta divided by itself is 1, and what we're left with is 2 times 1 over 1 times cosine theta, because this term reduced. So 2 over cosine theta, and I believe that's what we're ending up to look for. 2 over cosine theta. So there we have it. It's just this process of reducing this down as much as we can, and normally what's left is what we're showing, unless we need to do a little bit more simplification with other identities. So there we have it for a second video. This one's adding 2 terms together and creating that common denominator. Look for the third video. I hope this one helped. We'll see you soon.